Hi, everyone. I'm George Hantzaras. My background is in distributed systems, mainly big data engineering and cloud engineering. In 2016, I started working on blockchain technology. In 2017, we started this company called Tradeline. What we do in layman's terms is we automate workflows in the commodity trading and shipping industries. Now, the motivation of this talk was that we generally use terms like blockchain. We overhype terms, and we don't really care where these terms came from and how we started using them, and what was the need for a technology like blockchain. And I think in order to understand that, we should see what the predecessor was. And for blockchain, it was none other than distributed systems. And a distributed system is a collection of resources, a collection of computational resources that for the end user, it looks like a single system. So in order for us to do that, we need coherence, which means having a lot of different resources working together, being able to work together. And we also need uniformity, so a lot of different resources, different OSs, different hardwares, being able to look exactly the same for the end user. But this starts looking a bit complicated, so someone would ask, okay, why do we need distributed systems? And the two main motivations is scalability, because on a traditional architecture, you have a single node, CPU resources, memory resources, storage are finite. And of course, fault tolerance, because on a single node, well, you know what happens if that fails. So when you start to design a distributed system, there are a lot of stuff we usually don't take into consideration. More often than not, we consider the network resources being infinite, the bandwidth being infinite, the cost of data transport being zero, and that leads in a lot of issues. The most common being, the first actually that comes in mind, is that we have a problem with time. And then you say, okay, why is that important? Because when you have a lot of systems storing and processing the same data, you really care about the ordering of this data. You really care of what came first and what came second. And building distributed systems, you see that system clocks can't solve this problem. Even NTP, even protocols designed for distributed systems cannot solve this problem. So that's when we turn to logical clocks, like Lamport clocks, that is actually a convention between nodes of data ordering. Now, let's see actually what are the main concepts, the main things we have to have in mind when we start designing a distributed system. This is actually our engineering team deploying new code for the distributed system last night. Now, jokes aside, the main concept is time, as I told you, consistency inside the distributed system, and partitioning and replication within the data and the data processing inside the system. The fundamental concept of distributed computing is the CAP theorem. The CAP theorem says that you have to make compromises. You need consistency, availability, and network partition tolerance. But no matter how good your design is, you can only have 2 out of 3. So that's when you start hearing about eventual consistency and other concepts that you have to start compromising consistency and availability in order to design a distributed system. Now, partitioning is really important for the part of scalability. As I told you, one of the motivations to design a distributed system is scalability. In order to do that, you cannot have all the data replicated in all your nodes. So you need to shard, probably is another term you might have heard. You need to shard or partition your data and store different parts of it in each node. And another important concept is replication. This addresses the need of fault tolerance. So okay, it's good to partition your data, store different parts of your data in different servers, but what happens if one server fails? Then you need to have this data replicated in another server. But again, this solves a problem, but another problem arises because having the same part of the data replicated in different nodes, you can have some nodes disagreeing on what the truth is for the processing or for the data stored there. And that's where consensus comes in. We actually need an algorithm for these nodes to be able to talk with each other and be able to agree on what the value is of a certain distributed process or a certain partition of data stored. Now, as you can see, in a traditional architecture, you have a single source of truth, a single node, so there's no need for a consensus. Moving on to a distributed system, you have the big nodes, the master nodes, and then you have the storage nodes, the data nodes. So again, you have the master nodes that are responsible for consensus and are responsible to orchestrate this whole process. But still, this is a single point of failure. Even if you have redundancy there, these are a single point of failure. So that's when we ended up to the need of distributed systems. So distributed systems is just a special case. Decentralized systems is just a special case of distributed systems. The only difference is that the decision logic is included inside the worker nodes, the data processing and data storage nodes. That leads to more transparency because everything happens inside the storage nodes. All data is replicated in there, so we know at any given point in time what the snapshot of our system is. Leads to enhanced fault tolerance, better auditability, and of course, increased security. Now, the most popular decentralized systems, I'm pretty sure most of you have heard about it, it's the blockchain. Now, how the blockchain works is that it's nothing more than a ledger. You keep on writing and writing all transactions as they come in. All this information is encrypted and stored in the ledger, and everyone keeps a copy of the ledger. And when a new transaction comes in, or we need to read the transaction, then the consensus comes on board and we collaboratively decide what the truth really is. Now, let's see how a transaction works inside the blockchain, how we write data inside the blockchain. So the client, which would normally be your web app, your mobile app, or whatever that may be, submits a new transaction, requests to submit a new transaction, then the nodes check the validity that the actions you are trying to do are valid according to what you have described, and that you have access to do what you're trying to do. Once that is validated, then you submit the transaction, and according to what consensus algorithm, this is verified and then broadcasted to all the other nodes in order to append that to their ledger as well. For the consensus part, since as I told you, the decision logic is inside the data nodes, the consensus part is really important because this takes care of data corruption and data processing and validation of transaction and everything. So there are a lot of algorithms there. You have proof of work, which is probably what you've most heard of, which is the one used by Bitcoin. And others, proof of stake, and then going down for more traditional consensus mechanism like Byzantine fault tolerance, Raft, and so on. But, okay, all this seems good, but when do you need the blockchain and when do you need a traditional distributed system or a distributed database? And the difference is that the rule of thumb actually is that if you have a high throughput, customer-facing application, you normally cannot use blockchain because the data processing speed is pretty slow. But then if your identity management is important, if trust is important, if you have to program a certain set of business rules, then blockchain might be what you're looking for. And even if you need the blockchain, then you have to make some more decisions. Public, private, permissioned, and what's the difference there? So public is an open network. It's a network where everyone in here can spin up a server and join the network and start validating transactions. As you understand, this network lacks trust between the participants. So you need a more complex algorithm in order to validate the transaction, which means more processing power, more expensive transaction validation. Going to the private, you can restrict the access on who joins the network, so you can have some level of trust, which can bring down the costs of the transaction and lower your energy consumption. And then we reach to a point where we can talk about enterprise blockchain today, which is nothing else than blockchain which is designed to address real business needs rather than just transporting values from one user to the other. So by the term enterprise blockchain, we mean blockchain that can be configured according to your organization needs and can integrate with your current enterprise software infrastructure. And some application for this software are shown here. Usually, it's used for contractual data, identity management, proof of ownerships, and so on. Now, when it comes to using blockchain, the first thing you have to do is to be able to describe your business as well as the whole market within the network. So first of all, you have to ask yourself, do I need a private network or a public network? Do I need permission? Do I have to break my network into sub-networks, channels? Do I have to have different access levels, different policies? And finally, one of the biggest problems, how is the network administration going to happen? Who is going to be responsible for updating the code, submitting patches, adding organizations, and so on? Now, in order to give you a bit of insight on the decision that we took on these problems, let me describe your use case. So we want to create a software that gives the ability to two different companies to agree on a contract that one company is buying a shipload of crude oil from the other, agreeing on that, signing the contract. Then we needed to onboard the bank in order to finance this deal. And then we needed to onboard a bunch of other companies with different access levels in order to orchestrate the transportation of the cargo. So our decision was to make a private permission network because we wanted to control who joins the network and who doesn't. And we also wanted to be able to have different access levels on the network participants. We also wanted different channels, different sub-networks, because people who are trading crude oil and people who are trading metals don't want nothing to do with each other. Finally, we wanted to be able to onboard new organizations in our network, but each organization wanted to manage their own users. So we are responsible for just adding organizations, developing code updates, patches, but then even those, we cannot deploy those. We have to push this to a repository, and then our clients are responsible to update their node. And this is a pretty significant overhead someone has to have in mind, because you have to orchestrate with IT departments in large companies if you want to deploy your own code, which is an unusual overhead we are not used to. Now, some issues we had, the most significant one when we started is that blockchain is overhyped. A lot of people think they know stuff, but they don't really know. There's a huge confusion between cryptocurrencies and blockchain, and everyone thinks that, you know, if they use a blockchain software, they have to pay with crypto and that kind of stuff. So we had to re-educate the market. We had to overcome these problems. Unfortunately, blockchain still is the most redundant data storage mechanism out there. You just keep replicating the whole set of your data everywhere. And we think that this is a part that will be overcome over the next couple of years. And of course, the replication of data stored in different parts of the world puts your data in different responsibilities and in different data privacy jurisdictions. So a European company wouldn't feel comfortable having their data behind the great big firewall or in other jurisdictions as well. And of course, something that not a lot of people think about is that you do have to reinvent the wheel. If you start developing a Java application now, you probably know how to do unit testing, you know how to deploy, and it's pretty trivial how you're going to do CI, CD, and everything else. But those are unknown problems when you start with blockchain. You have to customize all these workflows according to your business needs. Now, the next steps for us and what we see in the future, as I told you, we strongly believe that although blockchain has a lot of benefits, it is redundant, so the data storage model has to change. At the moment, we are designing and developing our own blockchain platform in order to overcome these problems, and we're planning for this to go open source next year. And although we are strong believers of blockchain, we believe it's kind of immature yet. The community is immature, so we need some time for this to become mainstream in order to solve these trivial problems we have already solved in all the other software we use. Thank you.